Hello everyone. So today we are solving a question of JEE 2020. This is from the topic of electrostatics and STEM combined because there is some concepts of spring and all will be used here. Also the concept of electrostatics because we are given some dipole and charges here. So let's see how we can solve this question. We'll first read the question. So they're given a spring of negligible unstretched length. So highlight this point that the spring's initial length is very small and the spring constant K is fixed at origin 0, 0. A point particle of mass m carrying some charge q is attached at another end and the entire system is kept on smooth horizontal surface. It means no kind of friction will be there. When a point dipole is pointing towards the charge q is fixed at the origin, spring gets attached like stretched to length L and attains a new equilibrium position. Now if the point mass is now displaced with slightly with delta m from the equilibrium, we have to tell it's the frequency of it. Okay, so let's see how we can do this. Okay, let me draw for the first initial scenario. So when there is no dipole here, what is it? It is nothing but it is at 0, 0 and very small spring. Okay, it's like that only. Okay. Now when we introduce dipole here, what happens? The charge which is present at this end, okay, by q charge, so it will get repelled. So it will repel such that it will balance the spring force in the presence of dipole here. Okay. So now what is the force experienced by this charge? It is nothing but Q into E. And what is E, which is given by the dipole, that is nothing but equal to 2K P by distance Q. What is the distance between them? It is given as L. So 2K P by L cube into Q. This will be the force experienced by, the electrostatic force experienced by the charge, which will be balanced by the spring force, that is nothing but equal to KL. Okay. So let me write it properly. So 2K P by L cube into Q is equal to KL. So we can mark this our equation here. Okay. Now moving on to another slide, what we can do now, if now it is displaced with some delta L. So let me draw this. Suppose this is the spring here. Its equilibrium position is like this. Now it gets a displacement of delta L from here. So what will be now the net force acting on it? Net force, it will be equal to the attraction force, that is will be due to the spring force. It will be equal to K times L plus delta L, and which will be opposed by the repulsion between dipole and the charge here, which will be equal to 2 Kp. Again, what is the net distance here now? It is nothing but L plus delta L Q and the Q here. Okay. Now, as given delta L is very much small like this, so we can first make it common. K L plus delta L minus 2K PQ by L cube. If we take common, what will be left is 1 plus delta L by L cube. So if we have seen this scenario before, that when delta L is so much less than L, what we can do here is we can use binomial expansion and write it as K times L plus delta L minus 2K PQ by L cube into 1 minus 3 delta L by L. Also, we know that, like we have made it earlier, proved it earlier, that 2K PQ by L cube is equal to nothing but KL. So we will write it as KL plus delta L minus 2, not 2, KL and plus 3KL delta L by L. I hope this is clear here. So what will be the net thing left here is that the net force is acting is equal to 4K times delta L. So I hope you have seen these equations before, like whenever it is in the form of F equal to Kx or minus Kx, like there's nothing to mention about the minus, because this is, we are considering it as attraction force here. So what is the frequency? It is nothing but 1 by 2 pi root under K by M. We have to take the K equivalent here. So what is K equivalent here? It is nothing but 4K. So what will be the net frequency here? It is 1 by 2 pi root under 4K by M. If we take 2 outside, so what we will get is 1 by pi root under k by m. I hope our answer was in somewhere in this format also. So we can see that at the place of delta, it is equal to pi, that is nothing but 3.1414. So you have to write up to 2 digits, that is 3.14. This is our answer. Thank you, everyone.